Hey guys, my name is Tensor. Welcome to another Rust WebAssembly tutorial. Today we're going to be looking at Stdweb, which is an alternative to the Wasm bindgen library that we've been looking at thus far. Now, while both Stdweb and the Wasm bindgen libraries essentially accomplish the same goals, the design philosophies behind these two libraries are quite a bit different. Stdweb exposes a full suite of web APIs directly through Rust, and we can even write JavaScript directly inside of macro blocks inside of our Rust code. Also, it's mainly built so that other people can build larger frameworks on top of it. One good example of this is the U framework, which we looked at a while back. Alright, so let's create our project. So this time we're just going to say cargo new, and the project name will just be Stdweb example. And this doesn't need to be a library because Stdlib allows us to build a full Rust application and then convert it completely into WebAssembly. After creating our project, we also want to install the Cargo Web tool. Now this is a tool that will help us compile our Stdweb project into WebAssembly. Alright, with that out of the way, let's actually jump into our cargo.toml file, and we just need to define the Stdweb dependency inside of here. So we just write Stdweb, and the current version is 0.4.7. Now we can come into our main.rs file and bring in the external crate for Stdweb, and don't forget to actually append it with an attribute so that we can use the macros inside of the actual library. So we just add the attribute macro use to the top of the external crate declaration. Now that we have the crate imported, let's start with something simple to kind of get the feel for how this actually works. Inside of our main function here, I've created a message variable which just says hello Wasm, and then we're popping open a macro called JSBang. And inside of this macro, we can literally write JavaScript code. So I can just write console log directly in here, and we need to use this specific syntax to reference the variable up here inside of the macro. Now, once we've created our project, we can jump back into our command line and we can use that web tool that we installed earlier. So we just say cargo web build, and then we want to specify the target. In this case, we're going to use wasm32 unknown unknown. And once that finishes, you'll see that it will actually create a JavaScript file and a WebAssembly file under the name of the actual project. Now what you want to do is actually get these two files and just paste them into an area where you can write an index.html file. So I've just created a folder called static, and I'm putting in the JavaScript file and the WebAssembly file. And here's what the actual JavaScript file looks like. It's quite a bit larger than any of the Wasm bindgen JavaScript files that we generated, and that's because this is a complete application. So now we can just create an index.html inside of this static folder and then reference the JavaScript module, just like this. So we just put in a script tag that points towards our Stdweb_example.js file. To actually run all of this, I recommend you install a plugin in Visual Studio Code called Live Server. This allows you to just serve any HTML or JavaScript files directly without having to write some kind of bundler like Webpack or use some kind of developer server. So here I have the live server, and I have it running on port 5500. And I can open up our index.html file here by just opening up localhost 5500/static/index.html. And you can see here directly in the console that we actually get the hello Wasm console log printout, and it works exactly as you'd expect it would. Stdweb allows us to directly interface with HTML canvas. Let's jump into our index.html here, and let's define a canvas element. And for this canvas element, I'm just going to give it an ID of viewport and then a width of 600 as well as a height of 600. Inside of our function main, we can call Stdweb initialize, which will initialize the library. Now let's make some imports from the Stdweb module. So we're going to bring in Stdweb web HTML element, canvas element, And this is a type that we can assign to our canvas when we bring it in with a selector. And then I'm also going to import Stdweb web, and I need to import the actual web module, so I'll just import self. But then I also need a few other types. So we want the canvas rendering context for 2D rendering. We also want the iEvent target. And this is essentially just an interface that we can use to allow objects to receive events. And then we also want the non-element parent node type. And this particular import is essentially just a mix-in that allows us to reference various common objects that are embedded in the document and various other parts of the JavaScript API. The final import that we want for now is from Stdweb unstable, and it's called try into. This allows us to cast one type into another, or at least try to cast it into another. So now that we have these imports, we can actually grab the canvas element from our index.html document. And we can grab it by using a function called getElementById and passing in the ID viewport, which we added to our canvas. Of course, this function brings back an option, so we need to unwrap it. And then we're going to use the try into function to try to make sure to cast it as a canvas element. And then we're going to have to unwrap that as well. Now that we have the actual canvas element, we can grab the canvas context, and this type will be our canvas rendering context 2D. So we just say let ctx equal canvas.getContext, and then of course we have to unwrap that from the result that we get back. Now that we have both the canvas and then the actual context from the canvas, let's create a function that will allow us to draw a box inside of the canvas. So here we have a function that takes in the context, so the canvas rendering context, and this needs to be a reference because we want to be able to pass it to multiple functions. Then we have the color, which we'll pass in as a slice of string, and then we have the position and the size, both of which are tuples of F64 numbers. So the position will have an X and a Y, and the size will have a width and a height. So now inside of this function, we can use our context to access the setFillStyleColor function and just pass in the color string. And then we can also use it to access a fillRectangle function where we can just pass in the items that are inside of our position 0, position 1, and size 0 and size 1. So we just pull them out of the tuples and pass them in here. Those of you who are familiar with Canvas inside of JavaScript will be familiar with a lot of these functions that we're using, and that's because the Stdweb library exposes these functions to us in a very simple API. So now inside of our main function, we can call drawBox. We pass in a reference to our context, then we pass in a slice of string, and then we can pass in two tuples, one for the position and then the other one for the size. So we'll position this one at 20 by 20 pixels, and then the size will be 150 by 100 pixels, and it will have a red color to it. We can create a few more boxes here, so let's create a green one and a blue one, and for these we'll just change the X position, and then we'll make them squares rather than a rectangle. So both of these will be 150 by 150, and then this one will be at X200, Y20, and then this one will be at X100, Y20. So they'll all be lined up on the Y-axis, but then they'll be scattered on the X-axis. At the bottom of our main function, we want to call Stdweb event loop, and we want to do this mainly to help make our application run more efficiently. This is a mandatory step if you're using the emscripten target compilation to create your Wasm, but because we're using the unknown compiler, it's not a mandatory step. The same is also the case for the initialization of the library up here. So both of these declarations we don't actually need, but I just want to add them just to show you guys that this does exist. Alright, so now let's build this application, and then we'll grab the generated JavaScript and WebAssembly and replace the old ones inside of our static folder here. Now we can open this up inside of our browser using our little developer server, and you can see here we have our 3 boxes and each one is a different color. So other than just manipulating canvas, we also have the ability to look at mouse events and keyboard events and various other events directly connected to these mouse and keyboard events. So here I've imported Stdweb traits iMouse event, and this is just a trait to track various mouse events. And then I've also brought in Stdweb web event, and there are quite a few imports here. So I've imported iEvent, iKeyboard event, key down event, key up event, keyboard location, mouse button, mouse down event, mouse move event, and mouse up event. And we're going to use these types and objects to allow us to sort of look at the user's mouse and keyboard events inside of our console. So let's start by looking at keyboard events. So we'll create a function called onKey. This will take in a string for the actual key. Then the location will be a keyboard location type, and then we'll have a boolean to tell whether or not this key has been pushed. And then we'll also return a boolean from the function. Inside of our function, let's define a location variable, and we'll use the format macro to format this particular location into a string. And then we can use another macro that's built into Stdweb to call on the console object. And the first argument in this console object is the actual function that we want to execute, which in this case is log. So this is like what we did before where we had JS pound and then we wrote console log, but instead we're writing console and then log, and then we're putting in the things that we want to have printed out. So we're going to print out a little key colon followed by our key, then we'll print out the location, and then we'll print out whether or not it has been pressed. So this will tell us inside of our console which keyboard keys the user is pushing inside of the web page. So now let's create a function for the actual mouse clicks. So here we want to take in the mouse button first, then we also want an argument for whether or not the button has been pushed, and then we want the position, which will be a tuple of 2 F64s, and then we'll output a boolean. So like with what we did with our keyboard, we'll take the mouse button type that we're getting in this function, and we'll use the format macro to turn it into a string. Then we'll use the console macro to call console log, and we'll put in the mouse position, which will take in position 0 and position 1, and then we'll also put in the mouse button and whether or not it has been pushed. So this will print out true or false. And then of course we'll return true, just like what we did with our keyboard here. Now if we jump back into our main function, we can create a bunch of event listeners which we can attach to the window object. So we can gain access to the window object just by calling web window, and here we have a function called add event listener, which takes in a first class function or a closure, which will allow us to then listen to the keyboard events or the mouse events or whatever types of events that we want to. So here for this one we'll listen to key down events. And now inside of this listener, we can call our onKey function, which we created below, by passing in the event key, which has the information on which key was pushed, the event location, which has the information on the actual keyboard location, and then we can push in the boolean, which will just be true all the time. And if this actually happens, so if it comes back as true, then we'll just call event prevent default, and this will stop our keyboard from manipulating the stuff inside of the window. So like if we push a bunch of buttons, it will not actually register except for inside of our console because that's where we're printing it out. Let's do the same thing for the key up event. So this is essentially just the same thing that we created up here for key down event, except instead we put in the type key up event rather than key down event. Now let's create some listeners for our mouse events. So we want to see if we have a mouse down event. And like with what we did above, we can call our onMouseClick function, pass in event.button, then true, and then pass in a tuple of event.clientX, and we want to cast this as an F64, and then we'll pass in event.clientY also as an X64. And again, if this comes back as true, which it always does, we'll have it prevent the default actions. So if we click on random things inside of the window, if say we had a button for instance, the click wouldn't actually register on the button. And we can also do the same thing for the mouse up event. So now we have both mouse down and mouse up, and this will then print out the events inside of our console. Also notice that we have false for mouse up event, and we also have false for key up event, whereas for the down events we're passing in true for these two. Alright, so now let's compile our project, and then we'll put the JavaScript and WebAssembly into our statics folder again. And now we can open up our server, and you can see here every single time I click we get these mouse positions, which gives us the actual position of the mouse, and then the button that was clicked. In this case it's always been left thus far, and then we get whether or not it has been clicked. So we get true and then we get false, because when I click down it passes in for the mouse button down, and then when I let go it passes in for mouse button up. The same goes for keyboard keys. So as I type on my keyboard, you can see here that we get a bunch of different keys being generated inside of the console. Now you can also see that if I try to use the keyboard shortcut to get rid of the console on this browser by typing in Control-Shift-I, it doesn't actually work. And that's a result of us making it so that when we actually put in a keyboard press, it prevents the default action, which would be to normally close the console and then open the console. And in fact, let's add an input here, and if I try to click into it, you can see it doesn't actually work. And then if I try to type, it still doesn't work, or use tab, again it doesn't work. And that's because we're preventing the mouse and the keyboard from interacting with the web page. Let's add one final function to this project before we wrap up. So I just want to make it so that we can see the mouse movements inside of the console in real time. So we'll create a function called onMouseMove. We'll throw in the position, which will be a tuple of F64s, and then it will output a boolean. And again, like we did before, we'll just call the console macro to call console log, and we'll print out the mouse position inside of parentheses. So position 0 and then position 1 concatenated with parentheses. And then we'll of course return true. Let's add the event listener. So now we have a window add event listener, this time for the mouse move event. And we're going to just say if on mouse move, then pass in the event client X as an F64 and the event client Y as an F64, and put it into a tuple. And this time, instead of just calling the event prevent default, we'll call our drawBox function, pass in a reference to our context, pass in an orange color, then we'll pass in the event X and the event Y, both being casted as an F64 and in a tuple for the position of our box, and then we'll have each of our boxes be just 10 by 10. So essentially as we drag the mouse around our screen, it will then create a bunch of boxes. And because we're using the reference to the context here, we need to make this closure into a move closure, so it moves the CTX into the closure itself. Alright, so now let's open this up inside of our web browser. And you can see here, if I drag this around outside of our canvas, we don't actually get any squares being drawn because it needs to be on the canvas. But as soon as I start dragging the mouse in our canvas, you can see orange squares get drawn everywhere the mouse goes. You can also see in our console we have all the mouse positions being printed out. So as you guys can see, Stdweb uses a slightly different approach to interoping with JavaScript than the Wasm bindgen library. Rather than having us actually define the functions from the JavaScript layer that we want to use inside of our program, we have all of them written inside of the library by default. Anyway guys, if you enjoyed this tutorial, feel free to like and subscribe. If you have any questions or comments, feel free to leave them in the box below. And if you dislike this video, then by all means downvote it as much as you like. Have a good night.